As in the previous video, we have discussed about the design procedure of a counter and what is a counter and what is the application of it. What is the application of a counter? Now here let we design a 2-bit synchronous binary counter. As per the procedure, the problem statement is given in the red example 1. Design a 2-bit synchronous binary counter. And a flip-flop is also given. You may use T or JK. Shall we use T here? Yes, T. Let me use T. For this problem statement, since it is a 2-bit, 2 digits comes into picture. It is A and B. Therefore, 2 binary digits 0, 0 comes into picture. For 2-bit value, the possible combination is 4. Therefore, the first value for a decimal is 0, the second is 1, and the third is 2, the fourth is 3. 0, 1, 2, 3. Therefore, the state diagram which is shown here in the left hand side of the slide, 0, 0, a circle is given which resembles a present state. When 0, 0 is the present state, the next state may be 0, 1, which is given as an arrow mark. And when 0, 1 is the present state, the next state is 1, 0. And 1, 0 is the present state, then the next state is 1, 1. And when 1, 1 is the present state, the next state is 0, 0. It goes as a cycle, right? Only 4 possible states comes into picture here. Right. Now, the next step, after drawing the state table, we have to do for the excitation table, the second step, the excitation table. See here, the excitation table is shown here. The present state as A, A1 and A0, and the next state is A1 plus and A0 plus, the next state. For the present state, as since there are 2 bits, the possible combination is 0, 0, 0, 1, 1, 0 and 1, 1. And for the next state, as per the state table, if 0, 0 is there, then the next state is 0, 1. If 0, 1 is there, then the next state is 1, 0. 1, 0 is there, then the next state is 1, 1. And when 1, 1 is there, which is written in the black, the next state is 0, 0, which is written in pink and green. Therefore, from the truth table of the T flip-flop, it is extracted as for TA1, as per the column wise, it is 0, 1, 0, 1. And for TA0, as per column wise, it is 4, 1, 1, 1. Now, since the output is there, we have to derive the expression, and the expression with the help of a K-map. See, the expression is shown here, S. This is the expression. For TA1, it is A0, and TA0, it is 1. Now, with this expression, we have to draw the logic diagram. Since there are 2 flip-flops, TA1 and TA0, we have to draw 2 flip-flops, and the 2 flip-flops are drawn here. As the equation which represents TA1 equal to A0 and TA0 equal to 1. Therefore, 2 flip-flops comes into picture. You have to draw the logic diagram with 2 T flip-flops. Then the logic diagram is drawn here. See the circuit? S. The logic diagram is drawn. T flip-flops, 2 T flip-flops or 2 JK flip-flops. If J and K, the terminal J and K is connected together, then it is T. Therefore, a JK flip-flop or a T flip-flop, A0 is drawn first and A1 is drawn second. And see, the pink color line is your clock pulse, pink or a dark blue. Dark blue is the clock pulse which is connected parallelly. Therefore, it is a synchronous counter. Therefore, it is a synchronous counter. And see, since TA not equal to 1, the J and K terminal is jointed together and the supply voltage 1, you mean plus VCC is given. 1, you mean plus VCC is given here. And TA1, the second flip-flop, is A0. Therefore, the output of first flip-flop, which is nothing but A0, or it is also called as Q0. The output of first flip-flop A0 is given to the input of the second flip-flop as J and K. Input of the second flip-flop as J and K. Therefore, there is only two connections. One is A0 is the output, A0 is the input for the second flip-flop, and 1 plus VCC is the input for the first flip-flop. And the output is taken as A0 and A1. The output is taken as A0 and A1. This logic diagram represents a 2-bit synchronous binary counter. This logic diagram represents a 2-bit synchronous binary counter. And let me design another special counter in the next video. Hope you understand this is a basic counter design, 2-bit synchronous binary counter. Hope you understand it. Thank you for patient listening.